All right, hey everybody, we're back with Objective 140. You might notice that I'm wearing the same clothes you saw in class because we're doing it during prep. That's what teachers do in their time off. They just do more school stuff.
Boo!
Thank you, Ms. Hyder. So Objective 140. Students will be able to plot points and understand the coordinate plane. Your very first bit of notes is actually not even going to be here. So this is the Cartesian coordinate system, and I think it's super interesting to figure out why is it called the Cartesian plane. So your very first assignment as part of this homework is to go back to the video drive and look where it says video 2 in Objective 140, and I want you in this space right here, this big open space, take notes on that Khan Academy video that actually tells you, like, where did this idea of the Cartesian coordinate plane come from? It's so cool. It's about an 11-minute video. Take as many notes as you need, and we'll come back in just a second. Definitely will check for this. Ms. Hyder and I have watched this, so take good notes. All right, you should have your video notes from that Khan Academy video right here. I thought one thing that Descartes did just so impressively was make the connection between algebra and geometry, and I think that video does a great job of showing you that connection. One thing I think it could have done a better job, and this probably wasn't its focus, was explain how do we get to this coordinate plane. Well, think back to chapter 1 when we first just explored number lines. This sort of gives us just the one dimension. You know, if we have positive numbers going this way and negative going that way, we could know like 1, 2, 3, and then negative 1, negative 2, negative 3. The coordinate plane allows us to move in 2 dimensions, and it's basically just another number line, but then turned up. So the positive stays where it would go if you flipped it up, and the negative comes down here. It really is just 2 number lines stacked on top of each other, and we call that the Cartesian coordinate plane. So now let's look at each of these definitions. The x-axis is, I hope you can see this marker okay, it's the horizontal axis. If you have trouble remembering x versus y axis, think about the x, think about the horizon. When the sun goes up, sun goes down across the horizon, that's the horizontal axis. It's the one that goes left, we can do that, left to right. That is the x-axis. Hopefully this green marker works. It does not. Now the y-axis is just the opposite. It's the vertical axis. It's the one that goes up and down. You can see from the picture that I drew here, the x-axis is the red. It's highlighted. It's the one going from left to right. The y-axis is going straight up and straight down. Now, one thing you should notice is the arrows on the end of the axis. Now we're on to arrows at the end of the axis. Notice how on every coordinate plane I've drawn so far, and in the video right up here, they have arrows at the end. That's very intentional. It's because that implies the lines go on forever, just as numbers go on to infinity. There's no end to our numeric system. It goes on forever. So whenever you draw a coordinate plane, you must include those arrows at the end. And what you'll find out is whenever we draw lines, or really any function, we're going to have arrows at the end that imply that these functions go on forever. It's only until you get to like piecewise functions that that's not true, but that's something you'll explore later on in Algebra 2 and probably even junior year. All right, now we have the point where the 2 lines intersect. When we say that, I'm actually going to recreate that exact same picture we just had. This is the point that this definition is talking about. Right here, that's called the origin, which makes sense. Like the word originate means where things start from. So that where the y and the x-axis, oh, it's the original, that's not true. Origin, it's where the y and the x-axis cross. That's what we call the origin. That's point 0, 0. Which means the x has a value of 0 and so does the y. Okay? And the 4 different regions, these are called quadrants. I'm going to do this fast. I'm sure you had this mentioned to you in middle school, but if we're looking at this coordinate plane, the top right one is always quadrant 1, and then it goes counterclockwise. So 2, 3, We use Roman numerals because that's how it was done when this coordinate plane was first introduced. Now, you have these definitions, but you're like, well, why do we need that? I want you to go back and actually label this coordinate plane with all this knowledge. So label the x and y axis, label the origin, label the quadrants. I also want you to number by ones the x and y axis. So number the positive, the negative by ones, okay? Make sure it's labeled accurately. All right, so we're on the next page here. This first definition of ordered pair or coordinate pair, well, the definition's right here. That's what an ordered pair is. It's an x-y pair. The x, actually, instead of giving that away, let's do it right here. That x coordinate, we could also say that x value tells us exactly how far left or right to move from the origin. And that's really important because it's a little bit different for the xy pair. So let's give an example. Let's say we had the pair 2, 3. I'm going to do a really quick sketch of a coordinate plane. So 1, 2, 3. So it's a positive 3, 1, 2, 3. It's a negative 3. This is the negative part of the y-axis, and negative 3. Okay? So if I was what, Ms. Hyder?
I'm so sorry. I love Mr. Riggs' definition, but I'm more visual with this, and the way I see it is I see x and y as directions, and together as a coordinate pair, it tells you the location on your coordinate plane.
That's true. I like that too. That's a good way to think about it. So you say direction, just like x tells you left to right, like that's your direction.
Exactly, and y tells you up or down, and then together they are an actual location on the coordinate.
That's a good way to think about it. I do like the idea of like it's a location. It tells you where to end up. Kind of like if you gave your friend directions, same idea. You go up a few blocks west and then south, like that would be directions as well. So in this case, the x tells us exactly how far to go left to right from the origin. Since this is positive 2, I'm going to go 1, 2, and now I'm right here. Now you can tell I have more in my directions to give, but right now I'm at that point that's 1, 2, 2 to the right from the origin. And that's where the y-coordinate comes in. The y-coordinate, I'm sure you're already ahead of me, the y-coordinate tells us exactly how far to go up or down, and it's up or down from the y-axis. And here's why. It's not from the origin, because look, we're already like in the middle of these directions. Like if you're going to a friend's house, you don't just like go back to your house and then go up. Like no, we're already here at this point, like 2, 0. And now I'm going to go up 3, 1, 2, 3. Now I'm right here at 2, 3. And that's that final location that this ordered pair told us to end up at. Now, look right here. We gave you a coordinate plane to kind of mess around with. We're asking this question, how does this concept connect to our previous objective about functions? Here are 2 questions. Write them down. And then take a second to actually think about them. You should have some answer. Some response. You don't have to be perfect because these are not easy questions, but how does plotting points relate to functions? So how does this process relate to functions? And then can you connect this to the idea of input and output? It might be helpful, kind of like the Khan Academy video just used an equation. It might be helpful to write your own y equals some sort of like 3x minus something equation to help you try to answer those questions. All right, so I'm going to pick it up here on page 6. Not going to do any of this first part for you. Just by the way, this is negative, 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 positive, but it's just asking you what quadrant would we expect those points to be in. If you're not sure, because you're not exactly sure how to plot points yet, then let's try a few of these examples together. Looking at point A, it's telling us the location of point A is at 4, 5. So I start here at the origin. 4 says I'm going 4 to the right. The reason I'm going right is because it's a positive value. This is the positive direction, negative direction. So I'm at 1, 2, 3, and 4. If you're someone who messes that up, you can do like a little, I don't know, loop or a wave, whatever you want to call it. 1, 2, 3, 4. And then up 1, 2, 3, 4, and 5. 2, 3, 4, and 5. And then that's where the order pair 4, 5 is. I'm going to erase that because the question specified at that point is called A. And the reason I went up is because that's a positive 5, and this is the positive direction for the y-axis, and the negative direction for the y-axis. So you might be like, yeah, I did some middle school, awesome. Then you should be really great at it, and it'll be easier to help your classmates during class time. Let's try a little tougher one. I'm going to try point E. Notice how the first value is -4. You always start at the origin. But now I'm going left because that's a negative value. I'm going 1, 2, 3, and 4. And now I'm here, but I'm not done. The y value is -2, so I'm going down 1, 2, and then that's where point E is. I'll try one more with point, I'm going to do point F. Now the x value is positive, so I'm going 1, 2, and 3, and then I'm going down 3 because it's -3, so 1, 2, and 3. Awesome, that's where point F is going to be. Finish labeling the rest on this. Make sure you answer the quadrants up here. And then right here, it shows you the final locations. It's asking you, can you give the coordinate points to identify them? The rest of the questions on this page we're not going to tackle. We have one more example, and then we're done. All right, we're here on example 4. This is the last one we're going to do together. Ms. Hyder's home is located at this point on the coordinate plane, point 2, 3. So the first thing I need to do is, again, I'm just doing a rough sketch. You're really encouraged. You should always have graph paper, but using graph paper for these assignments is such an easier way to do them accurately. Strongly encouraged. So I'm going to 1, 2, then down 1, 2, and 3. So that's where Ms. Hyder's home is located on this coordinate plane. In case you didn't know, the whole city of Chicago is actually laid out like a coordinate plane. Hopefully we'll have time to discuss it in class. But if you're curious, you should look up Chicago coordinate plane. It's super fascinating. So here's where Ms. Hyder's home is. It's saying the grocery store is located 4 blocks east. So 4 blocks east and then 3 blocks south. What's important here is it's not as straightforward as it might seem. If you're like me, you should draw, that's confusing, it's like a coordinate plane. I'm not drawing a coordinate plane, I'm just drawing like a little makeshift compass. Remember, north, south, east, and west. I'm one of those people, I always do never eat slimy worms. Because why would you want to? Some people do never eat soggy worms, slimy or soggy. They both sound revolting, okay? So that might help you remember which way are is it ordinal? What are they called? The compass locations. Ms. Hyder just froze up. That was funny. I wish you could have seen that. So yeah, that's how I remember the directions on a compass. So it's saying from her house, the grocery store is located 4 blocks east. So that means I'm going to move 4 units east. And east in this case is in the positive x direction. So I'm going 1, 2, 3, 4. I'm not done, but now I'm at point 6, -3. Because 2 plus 4 equals 6, so now I'm at point 6, -3, but that's not the final location, because then it says, in 3 blocks south. I should have drawn more of my coordinate plane, but south is going to be down in the y direction. So I'm going to erase this. I'm going 3 blocks south. So I'm here at -3, I'm going down 1, -4, -5, and -6. So that point's going to be 6, -6, and that's where the grocery store is located on this coordinate plane. We're not going to do any more examples. I'll give you a hint on example 5, though. There's a lot to it. It's such a good question. I hope you really enjoy it. I think you all can figure it out. So it's giving you enough information to try to figure out, here's the questions. What are the coordinate pairs of the northwest, the southeast, the southwest, and the northeast corner is given to you. It's saying this park is shaped in a square. Think about what we know about squares. That would help you out a lot. You're trying to figure out what are the ordered pairs of the other corners of this park. Super excited to discuss more in class. Make sure you finish whatever was assigned, and we will see you